All right, in this video, we're going to work example 4.2 from your notes packet. So this is a balance on what we call a batch mixing process. So before we kind of dive into the problem, I want to go through what's in the problem statement, show you what the flow chart looks like, and then we'll get into solving. So setting problems up is going to be the really big component of mass balances that it will basically make or break whether or not you can solve an equation when it comes to these problems, whether you can actually solve the problem, not necessarily the equation, but the problem itself. Because if you don't set the problem up correctly, there's going to be some trouble. So what I want to do is I want to just kind of read through the problem, show you what the flow diagram looks like, and then we'll talk about how we solve this. So we have two methanol water mixtures in separate flasks. So we have two species, methanol and water. There's two different streams. The first mixture contains 40% by weight methanol, and the second contains 70% by weight methanol. If 200 grams of the first mixture is combined with 10 grams of the second, what are the mass and composition of the product? So I'm going to actually make this a little bit bigger on a different piece of paper so that we can talk about this a little bit more. So we have our unit process, right? It doesn't matter what this is. In this case, we're mixing things inside of it. And our problem statement basically told us we have three streams. We have mixture 1 coming in, mixture 2 coming in, and some kind of product coming out. So what I'm going to do first to make my life a little bit easier is I'm going to label things. So this stream I'm calling A. This is mixture A. This stream I'm calling B. And let's call my product C. So remember, anything that's an input comes into the process. Anything that's an output leaves. Now, the problem told us that we have 200 grams of the first mixture. That's what this is here. So 200 total grams of the mixture. And it should be 150 grams of the second. So change that in your notes. This should be, let me pull this up so you can see. Sorry, this should be 150 right here. Apologies for that. Make sure you change that in your notes. And stream B. And then basically we don't know what's coming out, but that's something we want to find. The other thing that the problem tells us, it tells us we have 40% by weight methanol in the first stream. So that's what this is right here. 0.4 grams of methanol per gram total in the first stream, 40% by weight. So remember, if it's 40% by weight, right, that is a mass fraction of 0.4. That's what that translates to, right? So for labeling this in terms of variables, this is X sub A. By the same token, we can go down to stream B, right? This is our second mixture, and our second mixture has 70% ethanol. So this right here is X sub B. So this is methanol, which means that we have some methanol coming out, but we don't know what that is. So that's X over here, and we're going to call that X sub C. Okay? So that's the first thing on the diagram. Second thing on the diagram that's really critical is that these things are mixtures. There's two species of every single thing, right? So there's water and methanol in each of these streams. So there's some amount of grams H2O per gram total in every single one of these streams. Grams H2O per grams total, and then grams H2O per gram total, right? So there's a little bit of it in each stream. Now, we know that all of the mass fractions sum up to 1 in a system. So if we have two species, that means this mass fraction plus the mass fraction of water in the stream must equal to 1. So what that means is this number right here must be 0.6, because if we have 40% methanol, we have to have 60% water. There's nothing else that could be in this mixture. If we have three species, these things still have to sum up to 1, but we can't automatically say that water is 0.6. in this case. So by the same token, if this one is 70%, that means this one is 30%. And so we labeled this XA and XB, right? But really what we'd want to do is you'd want to say XB, comma, H2O, right? So subscripts, super important in this particular class. The other thing that we need to label on our process flow diagram, not only to get full credit in Dr. Elaine's class, but in order to make your life easier, is to come over here to water. We don't know what the composition coming out is, right? We don't know. But we know that this composition plus this composition must give us 1, which means that this value must be 1 minus X sub C, and that's related to methanol. So you can see how your subscripts get complicated real quick. Okay, so this is a fully labeled diagram. And the reason that we label all of our species and all of our flows is because it's really, really important we balance things by total mass or by species. We don't balance everything all in one. You have to balance species by species. So make that note, pause, do whatever note taking you need to do to make sure that you understand that. Okay? So we will start the next video with making sure that you can set up all of the general balance equations, and then we'll solve.